What are the most famous examples of unusual physics in history? Have you ever wondered how strange experiments in physics have changed our understanding of the universe? Let's take a look at some of the most famous examples that showcase unusual physics and their quirky results. First up is the Michelson-Morley Experiment from 1887. This experiment aimed to detect a supposed invisible medium called the luminiferous ether, which was thought to carry light waves. The researchers expected to find differences in the speed of light based on Earth's movement through this ether. Surprisingly, they found no difference at all. This unexpected result contradicted existing beliefs and set the stage for Albert Einstein's theory of special relativity, which showed that light does not need a medium to travel. Next, we have Thomas Young's double-slit experiment from 1801. Young demonstrated that light behaves as a wave by shining it through two closely spaced slits. The result was an interference pattern of light and dark bands, challenging the particle theory of light. Later, this experiment was repeated with electrons, revealing wave-particle duality, a key concept in quantum mechanics. Moving on to the 17th century, we find Galileo's experiments on falling bodies. He dropped balls of different masses from the Leaning Tower of Pisa and rolled balls down inclined planes. His findings showed that objects fall at the same rate, regardless of mass, contradicting Aristotle's long-held belief. This was a significant step in understanding gravity and motion. In 1911, Ernest Rutherford conducted his famous gold foil experiment. He fired alpha particles at thin gold foil, expecting them to pass straight through. Instead, some particles bounced back, revealing that atoms have a tiny, dense, positively charged nucleus surrounded by mostly empty space. This overturned the previous plum pudding model of the atom and introduced the nuclear model. Robert Millikan's oil drop experiment in the early 1900s measured the electric charge of a single electron. By balancing gravitational and electric forces on tiny charged oil droplets, he confirmed the quantization of electric charge, establishing the electron as a fundamental particle. Léon Foucault's pendulum in 1850 provided direct evidence of Earth's rotation. He suspended a large pendulum that swung freely in any direction. Over time, the plane of the pendulum's swing appeared to rotate, making this subtle effect visible through clever experimental design. Another fascinating example is Schrodinger's cat thought experiment from 1935. Although not a physical experiment, it illustrated the strange nature of quantum mechanics. Schrödinger imagined a cat in a sealed box that could be both alive and dead depending on a quantum event, highlighting the weirdness of quantum superposition. Finally, in 1942, Enrico Fermi created the first controlled nuclear fission chain reaction. This experiment demonstrated that splitting uranium atoms could release enormous energy, transforming theoretical physics into practical applications for power generation and weaponry. These experiments stand out not just for their scientific importance but also for their surprising results that challenged existing beliefs. They reveal hidden aspects of nature and are perfect examples of unusual physics. The practical applications from these findings have shaped modern electronics, nuclear energy, and even global positioning systems that rely on relativity.